Hey there, this is Dr. Rishi from the Learners Academy, and today we are going to continue the journey which we started in the last episode where we talked about exponents. In the last episode, when we talked about exponents, we talked when the bases of the exponents are same. So let us go over it one more time in brief. So any number, if it's written like this, say I have 5 to the power of 2, then this 2 would be the index and this 5 would be called as the base. Now in the previous case we talked about it, and we said we talked only when the bases were same. In today's video we are going to talk when we have two different numbers as bases, and then we'll see what happens when we raise their powers, or we deal with the exponents of two different numbers. So let's go ahead with it. So now let us consider, so there are few laws that we have to take into consideration when we are going to talk about two numbers who are different and they're raised to a power. Now here let's go ahead with these laws first. Now if we have two numbers, let's consider them to be A and B, and we multiply them together. So if it's A multiplied B and it is raised to the power of M, then the answer would be A to the power of M multiplied by B to the power of M. At the same time, if we do division, we'll get a similar kind of result. So if we have A upon B and we raise it to the power of say M, then the final answer would be A raised to power M upon B raised to power M. However, the same thing would not be true when we are dealing with addition or subtraction of two numbers. So effectively, if we have A plus B and we raise it to the power of M, then it would be not equal to A to the power of M plus B to the power of M. The same way, if it's A minus B and we raise it to the power of M, then it would not be equal to A to the power of M minus B to the power of M. Now there are so many students who make mistakes when dealing with these two equations particularly, or these two exponents. This we would be dealing with these in a chapter called expansions, which we would be uploading a video in the later part of our series. Okay, so let's not consider these two, but these are the two that we are going to focus as of now. Now let's go ahead and check out few examples that are dealing with the multiplication or the product rule. So if I have say 3 multiplied by 4 to the power of 2, then this can be written as 3 to the power of 2 multiplied by 4 to the power of 2, giving me 3 multiplied by 3 multiplied by 4 multiplied by 4. Okay, so this would be 9 multiplied by 16, giving me 144. Yeah. Let's go ahead and check out the quotient rule. What happens with the quotient rule when we have two numbers and we divide them and we take the powers? So the rule says that if we take A to the power of A upon B to the power of M, then it would be A to the power of M upon B to the power of M. So again, we can take a similar example, say 5 upon 4 to the power of 3. So it would be 5 to the power of 3 upon 4 to the power of 3, giving me 125 upon 64. Okay, so far we've discussed what happens when we change the bases. In the first video we talked about exponents, and in that video the exponents were natural numbers or integers for that matter. Now what happens if they are not integers but they are fractions? So let us see how we are going to deal with numbers which are having powers which are not an integer, like they are basically fractions. Now this can be done only if our base is a non-zero number. So the first condition that we need to follow here is that A, that is our base, should not be equal to 0. Then only I can raise the powers of A's to a fraction. Okay, so before we go ahead with the fractions, let us first talk about the simplest form of the fractions that we are going to get. So let us consider what happens when a is taken to the power of, say, 1 upon n. The numerator is 1 and the numerator of my power is 1, and the denominator can be any number, a positive or a negative number, it would not matter. So in this case, we are basically going to take it as the nth root of a. So a to the power of 1 upon n would effectively mean a to the power of, or it would be nth root of a. So a to the power of 1 upon n would be equal to the nth root of a. That is, we are going to take the nth root. Okay. So when we were taking exponents as integers, we were multiplying them together. Now if we are taking them as fractions and we have our numerator as 1 and denominator as any integer, then we need to take the root or the root of that order. So let's take an example of this. Say suppose we have 100 and we take it to the power of a half, then it would be square root of 100. So it would come to 10. If we take say 144 and we raise it to the power of half, then we take a square root of it. So it would be square root of 144 giving me 12. Let's change the number n. Let's have, say, 27 to the power of 1 by 3. So that would be the cube root of 27. That would be 3. And we would proceed with this manner. Yeah. Now, so far we dealt with a to the power of 1 upon n, where the numerator of the power was 1. What happens if the numerator of power is not 1? Now say let's take, say, we have a to the power of m upon n. So instead of 1, we have changed it to a power m. So this would effectively be the nth root of a to the power of m. So first we take the nth root of a and then raise a to the power m. That is, multiply a m times. So if let's go ahead and take some examples on this as well. So say I have say 27 to the power of 2 by 3. It would effectively mean that it is the cube root of 27, which is raised to the power 2. Now we can write it this way, or we can also write it as cube root of 27 to the power of 2. The answer that I would get is, in this case, the answer that I would get is 3 square, so that would be equal to 9. If we did it with this way itself, then we first will have to write the square of 27 and then take the cube root. It would effectively give us same answer. So that would be 7 cube root of 729. So that would effectively again be equal to 9. So which method you do, which method that you utilize is irrelevant. It gives us the same answer. Whether you first take the square and then take a cube root, or first take the cube root and then take the square, the answer would be same at the end. Okay. So let's go ahead and talk about one more rule that is there. So we have discussed what happens when the power is an integer, when the power is a fraction. Now let us see what happens when the power is a negative number. So for this also we'll need our base to be not equal to 0. So the power is negative. So I have a to the power of minus n. So this effectively would be 1 upon a to the power of n. Okay. Here also a cannot be 0. Now we've seen that in previous 3 laws a cannot be 0. It is because a would be on the denominator side, and if the denominator is 0, the final answer would not be defined. Now let's go ahead and talk about some examples that are here. So let's say we have 10 to the power of minus 2, then it would be written as 1 upon 10 square or 1 upon 100. If I have say 3 to the power of minus 5, or that would be 1 upon 3 to the power of 5. So that I can write it as 1 upon 3 into 3. So it would be 1 upon 243. Yeah. So this is what would happen when the power is going to be a negative number. So let's have a revision on all the things that we did. First we took powers of numbers which were same. They were multiplied or divided. Then we took two different numbers and their powers, they were multiplied, divided. Then we took the powers were first integers, then we took them as fractions whose numerator was 1. Then we took them as fractions whose numerators were not 1, so there were other numbers. Then we took the powers to be negative numbers. Now we come to the last part where we take the power is equal to 0. So for any integer, if its power is equal to 0, then the number would be equal to 1. So any number to the power 0 would be 1, including 1. So any number a to the power of 0 is always going to be equal to 1. Even if it is 0 to the power of 0, then it is equal to 1. Now this is the only scenario where a 0 can be equal to 1 or any other number would be equal to 1. Now let's go ahead and solve some examples that are involving exponents in them. This one particular kind of examples, most of my students find it to be difficult, so I would be solving those kind of examples here. So in these examples we have there is a variable in the exponent and we have to solve it to find the value of the variable. Here we have the given example is 2 to the power of 2x plus 3 minus 9 multiplied by 2 to the power of x plus 1 is equal to 0. We have to find the value of x in this case. So the example says 2 to the power of 2x plus 3 minus 9 times 2 to the power of x plus 1 is equal to 0. And we have to find the value of x. It looks slightly complicated, however it's pretty easy once we start solving it. So what can we write here? So I can write it as 2 to the power of 2x multiplied by 2 to the power of 3 minus 9 multiplied by 2 to the power of x plus 1 is equal to 0. This I can take it further and I can write it as 2 to the power of x square multiplied by 8 minus 9 times 2 to the power of x plus 1 is equal to 0. Now I'm going to do a very smart trick here. I'm going to replace this 2 to the power of x by a variable. So I'll say that by putting y is equal to 2 to the power of x, I'll get, so this would be 8y square minus 9y plus 1 is equal to 0. Now this is a simple quadratic equation which I can solve, get the values of y, substitute them and then get the value of my x. So let's go ahead and solve this. So this can be written as 8y square minus 8y minus y plus 1 is equal to 0, giving me 8y multiplied by y minus 1 minus 1 multiplied by y minus 1 is equal to 0, giving me y minus 1 multiplied by 8y minus 1 is equal to 0. So this further can be solved by saying that either, now if two numbers are multiplied together, then either one of them is 0. So I can comfortably say y minus 1 is equal to 0 or 8y minus 1 is equal to 0, giving me y is equal to 1 or 8y is equal to 1 or y is equal to 1 upon 8. Now when we talked about it, what have we assumed? That my y is equal to 2 to the power of x. So 2 to the power of x is equal to 1 or 2 to the power of x is equal to 1 by 8. Now 1 by 8 I can write it in as a power of 2. It would be 2 to the power of minus 3. So I can say that, so from this I can conclude that x is equal to 0, because anything to the power of 0 is 1, or 2 to the power of x is equal to 2 to the power of minus 3. Therefore, x is equal to 0 or x is equal to minus 3. So these are the values of x that we were looking for. So this is a pretty interesting example. Let's do one more such an example. Now this predominantly is there in 8th and 9th ICSE and 8th and 9th State Board and 9th Standard CBSE. However, you do need this knowledge when we go for 11th Standard Science, specifically when we take maths or we use physics, because we take physics, because exponents are used in physics as well, and they're used in physics a lot when we talk about, say, units, when we talk about naming the units in a specific way or writing the units in a specific way. Let's go ahead and do one more such an example where we find the value of x, but in a different manner. Now the next example that we have is 49 to the power of x plus 4 is equal to 7 square plus 343 to the power of x plus 1. This example will be done in a different manner, however we'll get similar answer. So here the example says that it is 49 to the power of 4 x plus 4 is equal to 7 to the power of 2 multiplied by 343 to the power of x plus 1. Now the interesting thing here is that 49, 7 and 343 are all powers of 7. So first thing we'll have to do is make sure that their bases are equal. So we are going to write 7 square, 49 is 7 square to the power of x plus 4 is equal to 7 square multiplied by 7 cube, 343 is 7's cube multiplied by x plus 1. So we'll use the power rule to simplify these two parts. So power rule tells us that a to the power of m to the power of n would be equal to a to the power of m multiplied by n. So I can write it as 7 to the power of 2 times x plus 4 is equal to 7 square multiplied by 7 to the power of 3 times x plus 1. So the rule that I'm using here is a to the power of m to the power of n is equal to a to the power of m into n. Also writing the rules here so that you don't have to go back and forth. So this gives me 7 to the power of 2x plus 8 is equal to 7 square multiplied by 7 to the power of 3x plus 3. Now, since these two are multiplied, we would be using the product rule, which would be adding the exponents, giving me 7 to the power of 2x plus 8 is equal to 7 to the power of 3x plus 3 plus 2. I'll write the rule here. A to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. I would end up with 7 to the power of 2x plus 8 is equal to 7 to the power of 3x plus 5. Now, if the bases are same and the two exponents are equal, which it would mean that their powers are also going to be equal. So we'll use the rule here. So we can say that 2x plus 8 is equal to 3x plus 5. The rule we are going to use here is a to the power of m is equal to a to the power of n. It would imply that m is equal to n. So when we solve it further, we can take this 2x on the other side, this 5 on this side, and we'll get the answer as 8 minus 5 is equal to 3x minus 2x, or giving me x is equal to 3, which would be my final answer. Okay, so this is a way in which we can solve these kind of sums. So guys, that was it about exponents. In case you have any queries, please feel free to go to the comment section and comment your doubts. If you found this video helpful, please like the video and share it, and please do subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.